Okay, so just the one example for you on second derivatives of implicit functions. Okay, it's as it's implied, but we need to differentiate it twice, which poses a few problems. Okay, there's a certain format or certain way that's best to approach this. Okay, so I'll go through it in this example. Okay, so a simple question: find dy by dx and d squared y by dx squared for the function root x plus y cubed equal to 1. Right, so the first thing to do is put it in differentiable form. The first derivative should take care of itself. Okay, by now we should be at the point where we can kind of see where this is going. So the first, obviously, differentiation is just a half x to the power of minus a half plus this differentiated in terms of y is 3y squared, and then we just times it by dy by dx. The y, when differentiated, becomes 0. And obviously we're just going to rearrange so we get a function in terms of dy by dx, which isn't very pretty. Okay, we take that away first and then divide by 3y squared, but we can tidy it up a little bit. Just think of it as divide, but you probably want to deal with the indices first. Okay, so this will become minus 1 over 2 root x. Okay, and if we divide by 3y squared, we're basically timesing by 1 over 3y squared, in which case it kind of moves to the bottom. Right, you may ordinarily think that we take this and we differentiate this function, but what we're almost better off doing, okay, is differentiating it in a previous form, a previous unsimplified version. Okay, in other words, this version here. Okay, so pretty much the first one that we've differentiated. Right, buddy. Yeah, I'm just recording something, but you sure? Cheers, buddy. That was a clean. I'll just continue. So we take this version and we just differentiate it from here in the same way that we've done before. We're just going to split it up. We've got the two functions, so we can differentiate them separately. But this one here is obviously going to cause up a couple of problems, and there's a couple of things you need to be very aware of. Okay. Right, so the first bit we differentiate, it just becomes minus a quarter x to the power of minus 3 over 2. That's fine. Right, when we're differentiating this, we have to do it in terms of the product rule, hence we've got two things here. So again, we're differentiating the first part with respect, well, we're differentiating each half of this, so we're splitting it up. So 3y squared when differentiated will become 6y dy by dx. Okay, so what we're basically doing is we're then timesing by dy by dx, which brings in the dy by dx squared. Okay, so let me go through that again. So it's, if this is f of x and this is g of x, okay, when we differentiate this, in other words, we get f dash, we'd get 6y dy by dx, and obviously then when we then need to multiply it by our g of x. So it'll be 6y dy by dx times by dy by dx, which is 6y dy by dx squared. So then we do it in the reverse order, in which case we leave this as it is and we differentiate the second part and multiply them together. And dy by dx differentiated is just d squared y by dx squared, right? The mistake a lot of people make is that they assume that dy by dx times by dy by dx is d squared y by dx squared, okay? But obviously this is the derivative of the first derivative. This is literally just the first derivative squared. And if you apply that to kind of a really basic function, you'll see quite straightforwardly that that's not the same thing, okay? Right, but obviously at the end of all this, what we want is a function in terms of d squared y by dx squared. So we still have to rearrange this, but we don't want it in terms of dy by dx. Okay, so what we need to do with this dy by dx is substitute in the first one. Okay, so start by rearranging. You can start by moving some of it over. So everything that doesn't involve a d squared y by dx squared, we can shift over to the other side. Okay, and what we're then going to do is replace the dy by dx with what we got in the first function. Look at that. Okay. Now that's pretty nasty looking, but it does actually simplify quite nicely. Just be very, very careful with 6y squared. Still some of you jumping into this and just thinking, right, if I've got 6y on the top, which I will do in a second, okay, then it would simplify to just 6y. That's not the case. However, even before we do that, we have to do the squared part. And obviously, if we're squaring a function like this, we basically just square the top and square the bottom. As long as they're all multiplied together, we can literally just go through and square every part. Because at the end of the day, it's just 6y squared root x times by 6y squared root x. Okay, so this bit I've not touched, leaving the 3y squared where it is. I'm going to do this bit first. So when I square this, it just becomes 1. And bear in mind that the minus disappears over 36y to the power of 4x. And obviously when I times it by 6y, it simplifies to 1 over 6y cubed x. Okay. And all I need to do at the end of this is divide by 3y squared. In some instances, you might want to combine them into one function. It really doesn't matter. you either have a function like this and you leave it, or you actually go on and you actually find the nature of the stationary points in a situation like this. You're going to use it, so it doesn't matter kind of the simplest form that it's in. Something like this is absolutely fine. You can try and combine it into one function. It will eventually work, but it's just going to take you a long time, and it's not going to get you any extra marks.